Assalamualaikum warahmatullahi wabarakatuh and good afternoon.
Walaikum salam, Prof.
So for today's class, we will discuss on method of slices. Okay, if I'm not mistaken, I already discussed on the theoretical part based on my slide. Is it true? I have discussed the theoretical part, using my slide. Is it true or not? Hello?
I think yes, Prof.
Okay. So for today, we may go for several examples. Okay. So in order to make sure that you fully understand the methods. Okay. So for this method of slices, as we have discussed previously, so we may refer to the Fillenius, and also the modified methods. Okay. So as a recap, based on Dr. Kamaruddin example, so he has mentioned, or put some introduction, on the method of slices, which is shown in figure 1. So consider a slice having a width B and an average height H in figure 1. The developed shear resistance at the base of the slice is due to the width of the slice, which is the W, and internal friction angle of the soil. So based on moment equilibrium, the factor safety is a ratio between the resisting moment over driving moment. So when we look on this figure, for example, when we focus on one slice, so the first thing to do is to get what we call as the width of the slice. So when we have determined the width of the slice, then we get the center of the slice, and draw a straight line. I will show later on a I will sketch later. Okay. So then after that, so the center point or the center line, should extend, up to a certain length, after the base of the shell W, so represent the width of the center of the line. Then we extend up to certain length. After that, by referring to the center of the point of origin, so we use a long ruler. Then we draw a line, until it meets the center at the base, and then have some extension on the same line. So for example, the P naught, so this we consider as the strength of the extension from the origin. So you should have a protector. So by using a protector, you need to determine the alpha. So to solve the method of slices problems, you should have a protector, at least a 30 centimeter ruler, so easy for you to draw the line. And then you should put, or you should place your problems or draw the problems on a grid paper. Let's say this is the problems. So the best way is to plot or to draw on a grid paper. Okay, I will let you know why we should draw the problem on uh, the grid paper. Okay, so based on the filinears, okay, so we the value that we should use, okay, the alpha W, okay, how to get the W, okay. So for example, for this slice, okay, we determine the B, the width of the slice, and also the height based on the center line, okay. So then we multiply with the unit width, okay. So then we can get the W, okay. So what is the function of the alpha? The function of the alpha is to determine the length of the base, okay. And at the same time, what will be the moment, okay, based on the length of from the center, okay. So alpha will be used to determine the moment arm and also to be used to determine the length of the what we call it of the slide of the failure base. Okay, so this is the equation. Okay, based on the Fillenius. Okay, as I told you before. Okay, Fillenius has assumed that the side force is equal to 0. Okay, however, in order to improve the ordinary equation, okay, so then Fillenius add the pore water pressure, okay, in the equations. Okay, so equation one, okay, okay, to determine the factor safety. Okay, so C is the cohesion at the base of the slice. Okay, so we need to make sure that the C value should represent one type of soil only. Okay, we will discuss later. But what does it mean with one type of soil? Okay, so then C, L is the length. Okay, so W is the weight of the slice, cos alpha. Okay, minus UL. Okay, because the cos will be used. Okay, because the W should be changed. Okay, according to the failure surface. Okay, because on the top is the resisting moment, while the bottom part is the driving moment. Okay, so W cos alpha minus U ln, okay, tangent P. P is the value which is represent the soil at the base of the of the of the of the failure base. Okay, so then W sine alpha. Okay, so the sine alpha is the moment arm, while the W is the width of the slice. Okay, so this is C cohesion length. Okay, so this is the value to determine the length. P is the width. Okay, then we have P. Okay, W cos alpha, width of slice. Okay, pore water pressure, angle between the radius of the arch and the center of the base of slice, and vertical plane. Okay. So if I'm not mistaken, I already told you, okay, the alpha, okay, will depend on the from the point of the origin. Okay, for example, if the alpha is on the right side from the point of origin, okay, so we need to consistently use either negative or positive. Okay, for example, if the right represent positive, while for the alpha on the left represent negative. Okay, so for example, for this case, the alpha is on the right, so we may consider positive for this alpha. Okay, so that is for the Fillenius. Okay, so for the simplified Bishop method, okay, so due to some different assumption with the Fillenius, okay, where the Bishop assume there is a they consider the side force, okay, in the determination of the failure of the factor safety. Okay, So they have a vertical and also the horizontal. So both of the value has been considered, okay, and also include the what we call as the pore water pressure. Okay. So by assuming this kind of approach or this kind of assumption, okay, if I'm not mistaken, I already told you based on the force of polygon, okay. So later on the equation is become as shown in equation 2, okay. Y3, okay, is the uh, is a is a portion of or the explanation of the M alpha. Okay. So in that case, you need to determine first, or you need to do a try and error, okay, for the factor safety on the right, and make sure that factor safety on the left is equal to the factor safety on the right. Okay, the same procedure we do at least 3 attempts. Then we plot for the line of equality, the intersection between the line of equality and the relationship is the factor of safety value. Okay. Since Fs appear on both sides of the equation, okay, try and error procedure need to be performed to determine the factor of safety. Okay. Okay. So we go for two examples in Dr. Kamarudin and another example on Dr. Noli Gofar reference book. Okay. 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 So okay, this is the problem. As I told you before, okay, it's better for you to draw any problems on a grid paper. Okay, so then you need to scale exactly, okay, by using whatever scale, okay, either 1 to 2 or 1 to 1. Okay, for this case, one box, okay, represent 2 meter. Okay, so 1 centimeter represent 10 meter length or width. Okay. Okay. Okay, figure 1 show a slope with an assumed failure surface. If Fillenius method based on effective stress is used to analyze the slope, consider the slice number 3 and slice number 6 and fill in accompanying table. Assume the water table is far below the slope surface. Okay, so there is the water table is far. Okay, now we need to determine what is the calculation for the driving and the resisting moment for slice number 3 and also slice number 6. Okay, I need to change to a word version because I need to draw, okay, the procedure to determine the alpha and so on. Okay, so I stop first. Let me, okay. So easy for me to draw. Okay. Uh, okay. So the advantage of drawing or putting the solutions or the problems on the grid paper, okay. So it will make easy for you, okay, to determine what the length or the width. Okay. Okay. So okay. So for example for B, sorry, for number 3, okay, the width of the slice, okay, so we can, for example, I draw the width, I draw uh, the width of the slice, okay. So when we count, for example, the number of the box, okay, let me make it bigger. Okay, okay. So this is the, oh, you cannot see, I will use the red color. Can you see this red color?
Yes, yes.
Okay. Sorry, have I shared this
I think 5
notes
too.
on the e-learning? Sorry, have I shared this note in the e-learning?
Yes.
Yes,
Yes,
okay.
Prof. Okay.
Okay, good. Okay. So then we may count the number of the box. Okay, for example, 1, 2, 3, 4, 5. Okay. So 5 times 2 it will become 10. Okay, so the B for the slice number 3 is 10. Okay. So later on, okay, we may determine the center. Okay, definitely center will become 5, which is 10 over 2. Okay. So then we draw a line, okay, to represent the width. Okay. So this is will be the width. Okay. So due to the soil or the slice has two type of soil material, okay, which is soil number 1 and soil number 2, okay. So in order to obtain the W, okay, first we need to determine what is the height of soil number 1 time unit width of soil number 1 plus height of soil number 2, okay, time unit width of soil number 2. Okay, sorry, 2. Okay. So in that case, we may get the times B, sorry, times B. Okay, so B doesn't change because the B is equal to 10. Okay. So time B, HB gamma plus H2 times B times gamma 2. Okay. So then what is the value of the gamma? The value of the gamma is equal to 18 for the soil number 1 and 19.2 for soil number 2. Okay. So what is the value of the H1? Okay. So when we look on this table, okay, the H1 is equal to 8. Okay. While the H2 is equal to 12. Okay. So from there we can get the W. Okay. So for the W is the value for the average of the weight of soil number 1 plus the average of the weight of soil number 2. Okay. So the value for the W is 3780. Okay. So this is the value for the W. Okay. So then we may solve. Okay. For example, for this equation. Okay. So in order to solve this equation, okay, we may separate into 3 parts. Okay. So this will be number 1, okay, number 2, and number 3. Okay. So you need to solve, for example, number 1, then continue with number 2, and then continue with number 3. Okay. So the summation of this number 1 and number 2, okay, then divide with the number 3. Okay. So that is the best way to solve this problem. Do not count please do not count in total, okay, but separate it first. Okay, in, for example, for number 1, number 2, and number 3. Okay, because this is a part of all the total slice. Okay, we have here 7 slices. Okay, so for example, if you solve this number 3, okay, yeah, definitely may get vector safety for number 3. Okay. So then again you may repeat for saw number 2. Okay. So at the end you may total up the vector safety value. Okay. So that is for the W. Okay, now for the W sin alpha, which is for the driving moment. Okay, so this is for driving moment. So the author discuss first on the driving moment because it is a straightforward calculation. Okay, so the next is to solve the first part, okay, from the water, from the resisting moment. Yeah. By using the equation, okay, then C times B over cos alpha. Okay, so then the author obtained 355.4. Okay, then continue for the second equation, second sub-equation. Okay, so 3780 times cos alpha negative alpha 10 times tangent 30. So the author obtained to 149.23. Okay, because it doesn't have any water pressure. Okay, so it is a straightforward calculation. Okay, so that is for the sum number 3. Okay, look on the sum number 6. You may repeat the same procedure. Okay, first determine the width. Okay, so then get the center. Okay, from the center you may draw a straight line until it meet the what we call the center of the failure surface. Okay, so the same procedure, use the ruler and then determine the angle of the alpha value. Okay, which is this case the alpha value is equal to 37. Okay, so for this part the alpha is equal to positive, but for the earlier part the alpha is equal to negative. Okay, so then W sin alpha 3286 CLLN 438.25. Okay, so then we make sorry, not this one. So then we may count, okay, for the W cos alpha tangent phi 2517.56. Okay, so just include all the information, okay, in the what we call it in this box. Okay, and then you may solve for any next problem. Okay, for example, search number 1 until search number 7. Okay, so take note the strength parameter CNU used in the calculation are those at the base. Okay, so make sure that only one type of soil represent the value or the soil properties at the base. Okay, so negative angle value indicate the position of the slice is resisting sliding. Similar procedure are to be undertaken in other slice to obtain the overall safety of the slope with the trial and with the trial failure surface. Okay. Okay. So that is for the first example. Okay. So make sure that the soil at the base only cover for one type of soil. Okay. So let's say that's why in slide number 7, okay, so the soil is represent one type of soil, okay, while the slice number 6 only represent one type of soil. Okay. So for example, if the soil or if the slice has this kind of shape, okay, so it means that it has 7 on the 7 block, okay, on the slice of 7, okay, so it a portion of the soil properties at the base represented by soil number 1, and another portion of soil properties for at the base is based on soil number 2. Okay, so it can cause a difficulty, okay, in determining the what we call as the L, okay, sorry, L, okay, and also can effect on the factor safety value from the because we it's difficult for us, okay, to get what is to determine to include both type of soil, okay, in the calculation, okay. So that's why we need to make sure that only one type of soil, okay, is representing at the base of the slice. Okay. Okay. So now we move to the solution number 2. Okay. So for the solution number 2, so we refer to figure 3 and assume C page take place. Okay. So they have a C page here. Determine the safety factor again failure surface. Okay. So determine the factor safety against failure using the Fillenius based on effective stress, and another one simplified Bishop. Okay. So when we look on this example, okay, so the soil only cover one type of sorry, the slope only cover one type of soil. Okay. However, due to the groundwater table, okay, there is a slightly changes in terms of soil properties, okay, especially on the three parameter, which is the unit weight, C, and also the what we call as phi. For example, for the soil above ground table, this is the value 17.5, 10, and 15. Okay, while the soil below the groundwater table, the value is equal to 20 for saturated unit weight, 20 for the C, and 25 for the phi. Okay. So when we look on this example, okay, we may found that there is a groundwater level, okay, which is represented as a dash line. Okay. Then, in order to determine the HW, okay, so Dr. Kamarudin used a a flow net. Okay, this is a construction of flow net. Okay, so it's very difficult to calculate or to draw the flow net. Okay, to draw the flow net. Okay, so what is the function of the flow net? Is to determine what will be what is the height of the water, okay, based on the heat pressure. Okay, so I didn't see for any textbook, okay, they're using this kind of flow net approach, okay, except from Dr. Kamarudin. Okay, so in that case, okay, let's say this is the groundwater level, okay, So what should you do to determine the HW? Okay, so at least it should it should touch or it should meet the groundwater level rather than you draw the flow net. Okay, so it is okay for me for you to draw the height for the water, okay, based on the failure base to the groundwater level instead of you draw the flow net. Okay. So, okay, however, for this example, we refer to Dr. Kamarudin, okay, where he used the HW based on the flow net to determine the height of the water. Okay, and the H2 is the what we call as the height will represent the different type of soil properties because it is below the groundwater level. Okay, where or because the properties change, okay, when they meet the groundwater level. Okay, so for the H1 is represent the soil above the groundwater level, while for the H2 represent the soil below the groundwater table. Okay, so that is for the HW, H1 and H2. Okay, so for the solution to the problems can be easily performed by creating table, okay, as shown. Okay, so that's why in the example number 1, I already told you that you need to draw a table and then put all the important information in the table. Okay, for example, the B, the width, the L, the length, and the unit weight. Okay, then what we call as the alpha. Okay, so from there you may include the first sub-equation, followed by the second sub-equation, then followed by the third of sub-equation. Okay, so your table most likely like this. Okay, so you put the level of slash number. Okay. Okay, for example, this is slash number 6. Okay, then from there you put all the important parameter. Okay. So for the slash number 3, okay, of figure 3. So we look on the figure 3. Oh, sorry, this is the figure 3. Okay, so we look example of number 3. Okay, so for the slash number 3, okay, the unit weight times B times H1 is the value to determine the W. Okay, so for the soil number 1, okay, is 17.5 times 10 times 3. Okay, so in this case, we are using the height, okay, exactly similar with the one that has been shown in the table. Okay, so for sorry. Okay, so then that is for the H1, H2. Okay, so for the HW, okay, so the value is equal to 15.5. Okay, when we look on the diagram, okay, so the HW, okay, is less 3 meter compared to the H2. Okay, because the H2 is the second layer of soil. Okay, so if we refer to water table, okay, the height should be 18. Okay. However, when Dr. Kamarin used the flow net, okay, the height has been less to 2.5. Okay. 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 Then we have HW. Okay. Then start to calculate for the W. Okay. So for the W will become 4125. Okay. Two different units of soil above and groundwater table are considered in calculating the W. Okay. So that is what I want to tell you that by using the flow net, okay, the HW is less than the actual H2 or the soil represent for number. The height represent the soil number 2. Okay. So then we multiply the W with sine 5, okay, which is to get the what we call as the driving moment. Okay, so this is the driving moment. Okay, while this is for the resisting moment, which is for part 1 or sub equation number 1. Okay, so then calculate for the resisting moment, the thought for the portion number 2. Okay, okay, so then we already solved for the slice number 3. Okay, so since CPS is considered, okay, the pressure head HW is less than the depth of the water measured from the by drawing flow net. Okay, so this is what I told you, the flow net. So it's very tedious to draw the flow net. Okay, and I could not find for any textbook or reference book, okay, draw the flow net for this method of slices. Okay. So that's why I suggest for you, okay, if you have the groundwater level, so you just refer to the height from the base to the groundwater level to represent the HW. Okay. So then calculate for the PU minus ULN times tangent phi to obtain the sub-equation number 2 for the resisting moment. So then the value for the phi represent, okay, along the basic under consideration. Okay. So then the total value for the resisting moment, okay, is 1391.6 kilo. So that is the value for the resisting moment. Okay. So then the above steps are repeated for other slices in order to complete the table to obtain the overall safety factor. The tabulated value are shown in table 1. The factor safety is of resisting force in column 13 by the summation of the driving force in column number 8. Okay. So when you have this kind of problem in either Philinus or Bishop, okay, so you need to put in a table form. Okay. So then you begin with B alpha H1 H2. If the H2 is equal to HW, so it doesn't need to have HW. Okay, then start to calculate for W. Okay, this is the driving moment. Okay, so this is the first portion of resisting moment. Okay, while this is the second portion for the resisting moment. Okay, then the altogether the first and two portions from the resisting moment are listed in the last column. Okay. So once we already calculate for all slices, okay, So this value 8879.4 should be divided with the 9305.67. So the value is equal to 0.95. Okay. Wait a second. I need to charge my phone. Okay.
Okay, Doctor.
Okay. Now we move to the bishop. Okay. So similar procedure in creating a table are to be undertaken to solve the problem using the simplified bishop method. However, reader should realize the difference between Fillenius and bishop method in preparing the table. Okay. So this is some of the difference, which is CB, okay, while in Fillenius they use a CL, okay, UB instead of UL. Okay. So however, at the end you may refer to the full equation. Okay. So furthermore, okay, this is the main difference. Okay, the M alpha. Okay, so the M alpha factor, okay, in column 13 of table 2 based on equation 3 should be calculated by assuming a value of safety factor Fs. Note that when equation 3 is inserted in equation 2, Fs appear on both sides of equation 2. Therefore, iteration are required so that the value of Fs on the left side equal to the equation on the right side. Okay. So step to calculate M alpha for size number 3, assume factor safety 1.1 is illustrated. Okay. So Dr. Kamarudin show the calculations for the size number 3 by assuming factor safety equal to 1.1. Okay. So we can see it's very time consuming, okay, and very tedious work. Okay. So to begin with, okay, actually we may start by assuming factor safety is equal to 1.1. Okay. But we look on the calculation, so there is no calculation. Okay. So when we consider 1.1, okay, then we solve all the equation. Okay. So when then Dr. Kamaruddin obtained 1.14. Okay. So then he continue, okay, by assuming the factor safety is equal to 1.3. Okay. Then based on the calculation, okay, by dividing the resisting moment with the driving moment, so he obtained 1.16. Okay. Later on, Dr. Kamaruddin increased the factor safety to 1.5. Okay. Then he obtained 1.18. Okay. So this is the procedure for the method, for the simplified bishop methods. Okay. So once we already do at 3 attempts, okay, so the same procedure where we plot a graph and then we find the the intersection of relationship with the line of equality, okay, and it is equal to the factor safety value. Okay. Okay. So okay, the value for the simplified bishop is equal to 1.14. Okay, so when we compare with the Fillenius, the value is equal to 0.95. Okay, so in this case, as an engineer, it's better for us to use the lowest value, okay, in the design, okay, to ensure we have consider the most worst the worst scenario, okay, in our design. Okay, so at the end we may use the value from the Fillenius for these cases, for this case. Okay, so if you have two value, so use the lowest value. Okay, so in that case, it's better to conduct or to carry out for one analysis only. Okay, okay. So that is from Dr. Kamaruddin example. Okay, any question before I move to Dr. Noli Gofa example?
Clear.
I guess Dr. Kamaruddin example is the most easiest, okay, to understand. Okay, and I guess it's the most comprehensive methods or explanation, okay, compared to the other reference book. Okay, if you look on the reference other reference book, is very you need to you need to uh, do a lot of you need to refer to other reference as well. Okay, it's not as straightforward to understand. Okay, but when I look on Dr. Kamaruddin example, so it's very easy to understand. Okay, compared to Dr. Noli example. Okay, so now we move to Dr. Noli example. After that, we have a break. Okay. Wait, want to open Dr. Noli. Okay. So this example on Dr. Noli, we look on the method of slices. Okay. So no, I guess no need to explain it anymore. Okay, we just look on the example. Okay, so we look on this example. Calculate effector safety for a slope with the given planar plane in terms of effective strength concept. The slope angle is 45, height is 15.24. The shear strength parameter of the soil in layer A are C 17.1, Phi 18, unit weight 70.6, B Y C 0, Phi 34, and unit weight 19.2. Okay, so it only have 4 slices. Okay, 1, 2, 3, 4. Okay. And 2 type of soil, soil A, soil B. Okay. Then we may use the Fillenius equation, or for this case, Dr. Noli, we use an ordinary method of slices equation. Okay. So this is before improvement did by Fillenius. Okay. So for the case of no groundwater level, okay, W sin W cos alpha, okay, N for the N, okay. So then the cross section, okay, just simple like this. It's very hard to understand unless you put in what we call it in a grid paper. So based on the scale graph, okay. So that's why we need to put in the scale graph paper. Okay. So this is how they solve the problem. Okay, slice number 1 until 4. So at base A, B, 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 W, okay, W directly measure, okay, without explain in detail, okay. But Dr. Noli just mentioned here, okay. However, the most problem here is the alpha, okay. The alpha has not been discussed, okay. So the alpha has not been discussed here. Okay. So he just simplify, multiply W cos alpha tangent Phi, and also the Li. So Li should be on the alpha. Okay. So why this value is dash? Because the C is equal to 0. Because at the end, C times L will become 0. Okay. However, she need to put some value here. Okay, although it become a 0, so at least we know that the value it has a certain value. Okay, so not simply like that. Okay, so that's why I told Dr. Kamarudin example is very good. Okay, and easy to understand. So then W cos alpha tangent W sin alpha. Okay, so the alpha negative, we know that because it is located at the left side of the origin. However, no explanation is being made. Okay, so when we read on the first introduction part, I guess there are no explanations, either to use negative or positive, if I'm not mistaken. Okay, so no explanation on the alpha. Only mentioned here is alpha. Okay, it will make us confused. Okay. Okay, so that is for example number 1. Okay. Then for Fillenius, okay, that is for ordinary method. Then for the Fillenius, there are additional of the for water pressure. Okay. So then we look on the example. Okay. So the example P12 P512. Okay, so this is the example. Okay. Has 8 slices. Okay. So this is the groundwater level. Okay. So to determine the HW, okay, we look on the table. Okay, so okay, for this case, there are no seepage or there are no flow net. It's been drawn. Okay, so the height is depend from the base to the groundwater level. Okay, as I told you previously, it is straightforward. Except for Dr. Kamarudin, he used the flow net. Okay. However, there are no explanation on the flow net from Dr. Kamarudin in order in preparing the drawing, in preparing the flow net draw, the flow net drawing. Okay. So this is the HW. Okay. So very straightforward. W cos alpha, W sin alpha, nu. So if you want to determine, if you want to understand the nu, so you need to calculate the new value from the gamma W darab HW. Okay. Okay, so then you can get the new L, okay, the length, then later on the new L. Okay. So this is a portion of the equation from what we call as from the Fillenius. Okay, W cos, okay, CL. Okay. So no calculation for CL. Okay, so how come Dr. Nuli detail? Okay, the CL is the, okay, this is the L. So the C in this case is equal to 10. What is the value of C? The value of C is equal to 10. Okay, so it's provide here. Okay, so only one type of soil. Okay, so that is for Pillionist. Okay, now we move to Bishop. Okay, so Bishop. Okay, so this is the equation of Bishop. Okay. So this example of Bishop. Okay, I guess the same procedure. Okay, so I guess this is a very a big mistake here. Okay, where the soil, the base represent two type of soil. It's very difficult actually to get the value for the CL or the L value, because it cover two type of soil at the what we call it, at the base. Okay, because soil number 1, the C is equal to 25, while soil number 2, the C is equal to 7. However, in Dr. Noli Gopal calculation, the C, okay, for the slide number 9 is equal to 7 only. Okay, it's supposed equal to 25 and what the C, 25 and 7. It's not only rely on 7 only. And looks like 25 is most dominant compared to 7. Okay, so that is the another problems related to this example. Okay, so this is a very big mistake here for the 9. Okay, for the slash number 9. Okay, so 5.14. Okay, so this is 5.14. Okay, unit weight. I guess the same procedure, but for the slash number 1, okay, so she doesn't make what we call as try and error. Okay, I need to what is the value for the factor safety? So I guess she already used 1, okay, for the factor safety value, and then when the value is equal to 1.33, okay, after some try and error, but she doesn't prove it. Okay, so it's very difficult to understand the exact procedure. Okay, unless when we refer to Dr. Kamarudin show when we start with 1, what will be the passive value when we start with 1.3 and then we increase 1.5. Okay, so this is another big problem. Okay, for those who are not very familiar with these methods. Okay, how about for the last example? Okay, okay, so 1.4 directly she used 1.4, and after some trial and error, the final result is 1.432. Okay, so that doesn't show for any other trial and error methods, okay, in this example. Okay, so in that case, I can say that Dr. Kamarudin example is easy to understand, okay, and it is a very good explanation from Dr. Kamarudin. Okay, so any question from Dr. Noli method?
No, then.
Okay, so we take a break for 10 minutes, and then we will meet at 3:08. Okay. Okay. I will share for the attendance after the break. Okay.